Good morning. I'm Raleigh Flynn. I'm the president of the Foreign Policy Research Institute, a nonpartisan think tank based in Philadelphia. This morning, we have a program on small satellite proliferation, the advanced technologies and the security implications. It's a really important topic, and I'm really happy we're doing it. And we have some extraordinary panelists this morning with deep expertise. And to moderate the panel, we have Lawrence Rubin, who's Associate Professor in the Sam Nunn School of International Affairs at the Georgia Institute of Technology. And I will also add that he's one of FPRI's Templeton Fellows this year in the area of national security. Dr. Rubin, as I mentioned, is at Georgia Tech, but it was also the guest editor of the fall 2020 Orbis special issue on national security and technology, which was entitled Emerging Technology and National Security. It's a topic that FPRI has done some work on, and we'd like to do more. If you enjoy this program, please consider becoming a member if you aren't already. And I'd like to also say thank you to our donors and sponsors and members. And as I mentioned, if you're not already in one of those categories, please consider becoming a member or a donor, as we can't bring these programs to you without your support. At the bottom of your screen, you'll see a Q&A box. Roughly halfway through the program, we will go to Q&A, so put your questions in there and we will do our best to get to them. Without further ado, I'm going to turn it over now to Larry Rubin.
Thank you very much, Raleigh, and want to thanks for so much for the introduction. You've heard I'm an associate professor at Georgia Tech in the Sam Nunn School, and I have the great honor today of being the moderator for the event, Challenges and Opportunities of Advances in Satellite Technologies and National Security Perspective. And I want to begin also by thanking FPRI for hosting this event, as well as the co-sponsors, the Greater Philadelphia American Institute of Aeronautics and Astronomics, and the Center for International Strategy, Technology, and Policy, the Sam Nunn School of International Affairs, Georgia Tech. That's a mouthful. And last but not least, I want to also thank you, the audience. Our esteemed panelists today will examine the policy considerations and security implications of advances in small satellite proliferation and associated technologies. These advanced and advancing technologies continue to provide challenges and opportunities for actors in the government and commercial sectors who have the capabilities and those who seek to acquire them. The discussion today builds on some of the ideas from a recent Orbis fall 2020 article, which one of our panelists, Dr. Borowitz, as well as your moderator, co-authored, titled Emerging Satellite Technologies and National Security. And it comes from the special issue that Raleigh mentioned. And this is kind of third in a series of talks that deals with this concept and this idea that FPRI is really advancing of emerging technology and national security. But this panel today will go beyond the article to combine some of the sort of space policy perspective, technical perspective, and a national security perspective. And we have a great panel to do this, set of panelists here. The immediate context for this discussion, as probably many of you have heard, is the recent attention resulting from the uncontrolled re-entry of parts of China's Long March 5B rocket, which is the first part of its International Space Station. Many questions arose inside and outside various expert communities as to the significance of this event. While the risk of a casualty or damage was admittedly very low, many pointed out that this event highlighted the lack of rules or norms governing space debris or junk, which not only can fall to Earth, but can remain in orbit. In particular, we're reminded of the plans for large constellations of small satellites being created by private companies like SpaceX, which will further crowd the space environment with no clear way to regulate behavior, safety, or maintenance. As we'll hear later, these have important national security implications because the boundaries between civilian and military uses of these satellites may be blurred and possibly lead to intentional or inadvertent escalation among rivals should accidents or perceived nefarious activities occur. We must consider these important implications in the context of the reemergence, as we hear very often, of great power competition and the increasing number of state and non-state actors in space. But I'm going to stop here. And as I've asked our panelists to speak for a few minutes, addressing one or more of the following questions. What are some of the risks and opportunities of these dual use technologies? How do we ensure a space environment that's safe and sustainable, as well as a number of as well as the number of capabilities of objects in space increase? And can new technologies help mitigate the risks of international conflict over space? Tell the panelists, feel free to link any of your comments, of your response to the recent attention or discussion around the Chinese rocket issue. And now for the introductions of the panelists, to hear from them, our experts on these matters. First, we have Dr. Mariel Borowitz. Dr. Borowitz is Associate Professor in the Sam Nunn School of International Affairs at Georgia Tech, and her research deals largely with international space policy issues, such as space security, space situational awareness, data sharing, just to name a few. And Dr. Borowitz is widely cited in academic journals and press for research, and her book, Open Space, the Global Effort for Open Access to Environmental Satellite Data, was published by MIT Press in 2017. Also, importantly, Dr. Borowitz completed a detailed as a space policy analyst for the Science Mission Directorate at NASA headquarters in Washington, D.C. from 2016 to 2018. And our second speaker, Professor Glenn Leitzy, will share his thoughts from a technical perspective and go into a little more depth on where technology might provide challenges and opportunities. Dr. Leitzy is the David Lewis, a professor of space systems technology in the School of Aerospace Engineering at Georgia Tech, and he's the director of the Space Systems Design Lab and director of the Center for Space Technology and Research at Georgia Tech. He's published widely, extensively, and he's also the associate editor-in-chief of the Journal of Small Satellites, in addition to a number of other accolades. And last and certainly not least, we have Dr. Everett Doleman, and he's a professor of comparative military strategy at U.S. Air Force Air Command and Staff College, and his focus is on international relations and theory, and he's been identified as Air University's first space theorist. I think this is an important distinction in the sense of this new, so to speak, domain and combining it with the academic side of things and as well as space. And he's had a long career. He had a very celebrated and career in the intelligence community first, and then went into academia and spent time also at the United States Space Command. He's published numerous books on the subject, and most recently, as far as I can tell, the 2015 book, Can Science End War? He's also importantly a co-founder and editor emeritus of Astropolitics, the International Journal of Space Power and Policy. As you can tell, we have really a distinguished panel with, and I usually don't like to spend forever reading all their accolades, but it's really kind of informs where various participants are coming from. And I'm going to turn it over first to Dr. Borowitz, and she'll start with her opening presentation. At the very end of this, what we'll do, once they've all spoken, and throw your questions into the Q&A at any time, we'll turn it over to the audience after about halfway through, about 11:30, and then we'll go and we'll take questions from there. Thank you very much.
Great, thank you, Dr. Rubin, and very happy to be here today. So, as you asked, I want to talk to the issues with space debris and some of the issues related to security and sustainability of space. So the episode with the Chinese debris returning to Earth, I think, was useful in terms of raising some awareness of the existence of space debris, of the importance of space debris. But really, I would argue that it's the debris that stays in space that is of much more concern. So large objects like that don't come down very often, and when they do, the chances of someone or something actually getting hit are really quite low. But the damage that can be created by debris that remains in space is actually relatively high. So probably people are already aware if you've tuned into this event, but we rely very heavily on space for a wide variety of things. So a lot of our economy, a lot of our military and national security capability relies, at least in part, on satellites. And those satellites are at risk of collision just from other operational objects in space. I think there's more than 3,000 at this point, as well as pieces of debris. So there's more than 20,000 pieces of debris that are kind of 10 centimeters or larger, so large enough to destroy a spacecraft if they were to hit. And so because of that risk, we need to be ready to sort of take some action to deal with this problem. And I'm going to leave, there are some, technical things that we need to do and technologies that can help in this area. And I'll leave that more to Glenn and Everett. But I want to talk a little bit more about the kind of international cooperation and international security issues that we can address in this area, since that's my background. So there are a number of different areas, number of different levels on which we need international cooperation in order to address this problem. So the first is just getting good information. So a lot of my research deals with data and data sharing, and this is very much true in this domain. So when you're talking about space situational awareness data or space domain awareness data, basically just understanding what's in space, where it is, and where it's headed. That's step one, right? And right now we have in the United States a very advanced space situational awareness system. We do share that data internationally to some extent. But there are other programs in Russia and China and Europe that also collect space situational awareness data, and we don't always have the same picture of exactly where things are. And we certainly are not necessarily on the same page about what to do about it. So that's kind of the next step. Even if we can get the data shared, have a kind of a common picture of what's happening in space, we also need to decide, what do we do when we see a conjunction happening or a collision happening? Right now, this is a pretty ad hoc process. Each satellite operator sort of decides themselves when they get a conjunction warning from the United States, for example. Do they want to take action at all? If they're going to take action, what kind of action is it? There was an example, I think last summer, when the European Space Agency had a very large, capable satellite that was predicted to potentially have a collision with one of these small SpaceX satellites, part of the mega constellation. And, ESA did the equivalent of kind of emailing and calling SpaceX to try to decide what to do, and wasn't able to get in touch with them. So there was an issue with the communication, and ESA ended up just unilaterally deciding to move their very large and capable satellite, expending some of that fuel, decreasing the lifetime of that satellite, just because it wasn't clear, if or what SpaceX was doing on their side. And so, clearly that is not a sustainable situation. And that's something that we need to have coordination on the international level to deal with. And interestingly, we're still quite a ways from having that happen. So there's been some international agreements about preventing or mitigating the amount of debris in orbit. And there's a lot of discussion about this idea of space traffic management, right? Actually coordinating on what you do when there is a collision forecast, but not really any significant progress on that. And it's actually getting more complicated. And this was one of the focuses of the paper that Larry mentioned that was published in Orbis. As we're getting more capable in terms of what these objects in space can do, you're getting things like seeing more rendezvous and proximity operations, right? These are things the military in the US and elsewhere has been doing for quite some time, but getting possible for more actors. Included in that is on-orbit servicing, right? Where you're going to have a satellite purposefully get very close to another satellite, potentially actually attach to it to extend the lifetime or repair some object, some part of that satellite. And active debris removal, right, is also going to require getting close to other objects, interacting with other objects in space, potentially even objects that don't want to be interacted with. And this raises a whole nother level in terms of data sharing. How do we know, what objects are going to do these types of maneuvers, why they're doing those maneuvers, what their intentions are? That's all kind of an international collaboration kind of problem. And it's not a theoretical issue, right? So as I mentioned, the US has this capability. Russia and China have both had in the last couple of years satellites that are maneuvering around, particularly in the geostationary orbit. And in the case of Russia, actually maneuvering close to US satellites. And at this point, there's essentially no rules against that on the international level. And so even when the US raises a complaint to Russia, there's not any particular agreement or anything that they can point to. So it's hard to really make that argument. And so this is another step that we really need to do, is come up with those agreements. What's appropriate action in space? What level of information sharing is really required among international actors? And what actions are we all going to agree to in terms of keeping space sustainable and coordinating our activity there. Okay, so I think I'll stop there and pass on to the other panelists. I'm looking forward to questions.
Great. Thanks, Mariel. So hi, I'm Glenn Leitzy. I'm a professor in aerospace engineering. Prior to that, I worked at NASA for a little while. In my career, I've been fortunate to work on lots of satellites, a lot of small satellites, personally, probably more than a dozen now. And I've really seen the field change. I mean, I think over the last 30 years, we can say it's changed from a few nations and large companies that did everything in a very controlled way to much lower barriers to access to space. And, you know, this is, I think, by most people considered a good thing, right? It's not as limited as it used to be. And there's a lot more innovation happening and companies are getting involved. So there's, you see startup companies coming in all the time now. So most of us as, you know, kind of enthusiasts and people that believe that space technology helps quality of life on Earth, this is where we want to go, right? This bigger, more active environment is a natural progression for the space field. There isn't any alternative. I mean, the alternative is to go back to the old way of where there really wasn't much activity. So we have to learn to live with our own success, right? I mean, space has to learn, we have to learn how to manage this environment. And probably the first comment that can be said, and Mariel pointed this out, is we don't really have rules of the road at this point. Like you need to have certain agreements on things like what is acceptable space traffic density and how that affects what you can and can't do. There are certain orbits that are much more popular than others, and so you might be limited in your maneuverability in those orbits. There are analogies for this. You know, there are maritime and airspace treaties and regulations, and there really should be some analog for spacecraft. And I can think of, you know, general rules you would have. First of all, you would establish which spacecraft are maneuverable and which are non-maneuverable, because the non-maneuverable ones obviously can't do very much to get out of a situation. You might have separation, you might have relative velocity limits based on the separation distance or the orbit similarities. And then there are issues with spectrum coordination. You have to manage your spectrum so you're not blocking the ability to communicate with other satellites near you. So there's these rules of the road that need to be established. I do believe, some people say it's international, how do we enforce this? I do believe there could be significant successful enforcement mechanisms. The most obvious is launch access. Like launching a spacecraft is a pretty easy to monitor, detectable event. You can verify it. If we had international agreements and we had, and I'm really thinking about companies here, but if we had sort of irresponsible actors who did not take care of the space environment, you know, we could restrict their access. So I think there are ways to do it. There have to be agreements to do that. There could be fees, so forth, ways of managing that. We really have to think about maintaining the space environment. It's not something that is going to take care of itself. And I think the analogy, I kind of think of national parks. You know, that's an environment that we try to maintain. We keep it free of litter, and there's a park service that is funded by the government and also by private users of that domain. And there's a philosophy of leave it as you found it. And I think that really we need to have something like that for space, and you know, requirements for people to bring in their own deorbit mechanisms or things like that. In terms of what technology can do, I really think that we have to think of space as an active domain. The idea that satellites are just kind of up there in orbit, passive, and they're not maneuverable, I think that's an, you know, harder situation to manage. With more vehicles in orbit, we have to have sensing and we have to have maneuverability on those vehicles so they can coordinate their actions, so they can get out of the way of other vehicles if they need to do that. I really envision an environment where satellites are kind of working together collaboratively. There are things like autonomous collision avoidance, where you don't need human operators to do everything. You can actually have the satellite detect its own environment and maneuver to get out of the way if it needs to. Now, there are a lot of challenges with this. Our ability to do sensing on the spacecraft is very challenging, especially if the spacecraft is smaller, and that's the direction a lot of commercial spacecraft are headed. And interpreting all that information, the information processing and assessment on the vehicle. So we're not talking about space domain awareness from the ground. That is a critical feature. But as Mariel pointed out, oftentimes the ability to react is too slow if you bring the ground into the picture. So I envision kind of a more interactive space environment where the vehicles are sort of aware of what's in their immediate vicinity, and they have rules for how they handle traffic in the near domain, the near field. So obviously where we are is just at the very beginning of this new world, and I think there's a lot of work that needs to be done on the international policy and coordination, regulation field. We need experts, and we need interested stakeholders to come together and hammer out these agreements. And they're international, they involve multiple governments. So it's going to be quite complex, but we really have a responsibility to do that, to manage the growth that we all want to see in the space domain. And the way I think about it is, where do we want to be 20 years from now, right? How much more density is there, and how is that coordinated? And that's what we have to be working toward. So with that, I will pause and hand it over to Everett. Thank you.
Well, thank you, Mariel and Glenn. I think we're in pretty much agreement on the rules of the road approach and what that leads to, and certainly proximity and SSA requirements for technology. I focus more on the national security perspective from a military point of view. And 5 years ago, I was asked to put together an essay which turned into a short book called "Can Science End War?" And to get straight to the point, no, it cannot, at least not by itself. And this is because science and war share a great number of characteristics. Science is the relentless pursuit of knowledge concerning the underlying structure and practical activity of the natural world. War is the relentless pursuit of victory. And in both, there's no internal mechanism to limit that pursuit. To paraphrase Clausewitz, each has its own grammar, but not its own logic. Only an external rationality, the reason why these pursuits are undertaken, why these technologies are chosen, can limit science and war from continuing on theoretically to their own annihilation. Still, we've advanced as a species that any solution to the problem of war that is going to come out is going to have science and technology as a part of it. And the essential element here is that war is a uniquely human endeavor. Science is too, but one is dominated by emotion and the other by reason. And both have a very long shared history, because the practical output of modern science is often the technology developed specifically for war and war fighting, or adapted to it to make it more effective and efficient in killing and destruction. In the book, I charted the rise of both modern science and modern war, from the study and development of gunpowder, metallurgy, ballistics, through the growth in both scope and scale of war to the modern horrors of mass destruction. And in the process, I dismissed the logically trivial solution that we could end war if we can simply end humanity. I'm rejecting that one outright. You'll probably be happy to hear. One of the problems then I look at is, can scientists end war? And again, I find it unlikely, and there's some structural reasons for this. Scientists push the limits of their field to be the first to make a discovery, or simply see where the investigation leads. And so I begin the book with a description of the exhaustive, exciting, and enthusiastic efforts of scientists working on the Manhattan Project. They all knew they were building a bomb. They all knew it would be used in the ongoing war if it could be made operational. And only one scientist even raised the possibility that it might be immoral. After the first test detonation, the Trinity test, the lead scientist, Robert Oppenheimer, who learned Sanskrit in order to read the Bhagavad Gita in its original language, quoted, "Now I have become death, destroyer of worlds." Now, after the accomplishment, almost all of the scientists rejected the atomic weaponry and demanded or worked towards its elimination. And from Alfred Nobel and dynamite through the chemical wizards of World War I, and currently into areas of cyber technology, et cetera, regret seems to be something that happens only after we've pursued something to its end, and that makes it tough. I've also looked at efforts to use technology to make war less violent and less destructive, to include less than lethal and reversible effects weapons. But these two have the paradoxical effect of making war safe, which is an oxymoron in some ways, and in some ways escalating warlike activity rather than slowing it down. So I look at the motives for conflict and war and see if there's an underlying cause that we can get at indirectly. And I think of Thucydides and his dictum that war is caused by fear, greed, and honor. And where can we go with technology to sort of get at these and to mitigate these? And fortunately, and to get towards the end of the work, I look at space science and technology as having potential to eliminate these all through abundance coming from space solar power, from resources from space used and developed and in space to perhaps create a neo-industrial age, one that is green, one that also looks at getting rid of current radioactive and toxic wastes on Earth. Once we get space travel, maybe through SpaceX or something else that is as reliable and safe as air travel today, we'll be moving all of that toxic waste and radioactive waste that we spend about $500 million, about $50 billion here just in the United States on storing it. We can move that into the sun and permanently eliminate it. A green future of abundance looks possible through space technology, and in scarcity is where we have fear, the fear of loss. And in abundance, we have a lot more efforts towards cooperation. Perhaps to the surprise of many of those here, the U.S. military and more recently the U.S. Space Force has been a strong advocate of rules of the road approaches, and in fact worked with Britain and other allies that we have, including Japan and countries in Europe, to put forward a rules of the road resolution that was passed and endorsed by the United Nations December 7th of last year. The idea with rules of the road is that it creates cooperative efforts by giving a common picture of information. And that's where the efforts that you both talked about in space situational awareness is absolutely critical. And that space situational awareness capability that we have is run by the United States Air Force and now the U.S. Space Force. And we give that away to the world as part of what we consider to be responsible space behavior. That needs to be based in space, going through the atmosphere to find this stuff. That's why we have 20,000 objects, 10 centimeters or bigger, that we worry about on a daily basis. Space situational awareness can help us with collision avoidance and maneuver. But there's billions, possibly trillions of micro debris, man-made and natural, that could cause damage and even catastrophic damage. We also need to know when someone is attacking or targeting our spacecraft, and space situational awareness can give us that. It, again, needs, I think, to be in space, to be global, and to be immediate. We need to attribute bad behavior, identify it, isolate those who do it, and then go ahead and have some sort of a mechanism to enforce that commonly held or consensually determined rules of the road approach. How close is too close? When are you doing something that's interfering with someone else electronically, et cetera? When are you doing sort of a space piracy? We look at hacking and interfering with jamming, et cetera. These things have been going on for 40, 50 years. The problem is to limit conflict or war in space is a nice idea, but when war happens on Earth, and this is really an argument against war itself, it has, since at least Desert Storm and probably earlier, gone into space already. We have daily reports of jamming and interference with satellites, most of which turn out to be explainable and natural, but several, up to 5 a week on average, are considered deliberate targeting and attacks in space. As we get these mega constellations and we start looking at 5,000 satellite constellations, We start looking at the crowding and congestion of low Earth orbit. Of course, it's an enormous place, but still, because of the speeds involved, any collision could cause catastrophic debris. We need to be able to clean that up, not just mitigate or try to reduce the amount of it. And the problem is, of course, any ability to clean up debris is an effective space weapon. Who should have that? Who will have that? Well, internationally, states, and the states are the component of the United Nations system we have today. They are responsible for the behavior of its citizenry, its businesses, et cetera. And it is to them that if you have a grievance, that you get litigation to get that taken care of. The state then has to go ahead and get satisfaction from its citizenry and its businesses and corporations. We need to be able to, in states claim a monopoly on the legitimate use of violence. Domestically, that's police power, but internationally in commons areas, and the space, of course, is a commons non-sovereign area. The legitimate purveyor of violence is the military. And so the US Space Force is probably going to be called upon, hopefully in part of an international consortium. That is what we're working for. But we'll probably be called upon to go ahead and take care of those constabulary duties to make space situationists aware, to identify violators, to do such things as search and rescue operations when space tourism and commerce becomes more important, to protect those lines of commerce, those lines of communications and commerce in space, as the value from space now approaching $400 billion in direct value per year, far eclipsing even aviation, and trillions of dollars in value if you look at banking, internet activities, secure communications, et cetera, and new business plans. So the military may not want to take this role as space cop, but it probably will. It's going to need weaponry capabilities that are ideally non-kinetic. That means directed energy for proximity defense, for destroying micro debris, potentially even more capabilities, maybe even kinetic things. Again, probably something that doesn't cause additional debris. For Earth defense, we're looking at everything from comets and asteroids that could be potentially species killing, and that highlights the space as a global commons. We cannot do any of this stuff and just keep it to protect the United States or protect some parochial interest. It becomes protection of the entire globe. Ideally, this will lead to, through rules of the road, where we can anticipate future behavior, will lead to cooperative agreements and to a cooperative international force that can handle not only space traffic management, and that is the ultimate goal of rules of the road, is an enforceable space traffic management system that all states agree to participate in. And once that is established, we'll see more cooperation in space. We'll see less likelihood that war will go to space or start in space, as the shared capabilities of all states are known. Now, this comes from a philosophical direction or a philosophical basis in the old Roman adage, si vic pacem, para bellum. If you want peace, prepare for war. It's another paradox in warfare, space, and technology. But weaponry will have to be developed. Now, there's an alternative view, of course. If you want peace, prepare for peace. That is very persuasive to a number of folks, in which case the weapons of war, the military capability, needs to be eliminated, and that would prevent war. Since they're both assumptions and not really provable at this point, that depends on where you stand. Well, I've gone over my time, I believe. I'm going to go ahead and stop here, and I look forward to your questions.
Great, thank you so much for all of the panelists so far. And I think it's pretty clear, showing their expertise, that on various aspects of this, tackling many different issues, but in particular, we talked about kind of focusing more on the debris problem here. And I do want to actually start off this way. I have a number of my own questions, but I'll start with the first one because I'll sort of follow up from Everett, but I would like if Glenn and Mariel have their own comments to this. We have a Wasma Aman, my apologies if I mispronounced the name, student of politics from Afghanistan, asked an important question: what can be done to prevent the spread of weapons? And I want to kind of play this off to ask, is there a rules of the road approach for preventing we'll say, proliferation of weapons in space. We know we've talked about, in theory, what militarization really meant, or it always had thought by that in the past, but if there's a rules of the road approach to that. And also actually curious if Glenn or Mariel have any questions on that from their perspectives on seeing it. The other question is kind of related, and feel free to talk about, is our second one, coming from the use of how likely is war, maybe in space. We have a question asking about the use of satellites destroying missiles, but it's kind of all related to begin with. So I want to turn it over to you. If there's a rules of the road approach to proliferation that could eventually lead to some type of conflict in space itself.
Well, proliferation can't be complete in this sense. We're going to need some weaponry to do the cleanup and the necessary functions of defense for all nations and actors in space. So this would best be handled if we can get an agreeable consensus or a quorum of spacefaring states to participate equally, and that means absolute transparency of intelligence information, et cetera, and control over such weapons as would be necessary in order to be a constabulary for space. But it's a tough question because from where I sit, I don't really want to eliminate weapons in space. I find them to be necessary. I also find, and I won't spend any time on this, but a space-based missile defense system or a space-based defense system against high-value fleeting targets and space targeting systems on Earth, because what we have mostly now is Earth-based weapons that go into space and cause tremendous damage, but aren't stationed in space. That is the real problem that we're looking at. A global space defense system could prevent any incursion of, say, missiles across borders. One of the problems we have is not just defending ourselves, but what happens if there is a third-party war that starts, say, Israel and Iran exchanging nuclear weapons, or Pakistan and India, or, for example, or North Korea launching towards Japan. How do we stop that as a third party or as an international group? Other reasons that war might start include an accidental launch, an inadvertent activity, et cetera. And those cannot be deterred. Those can only be defended against. I'll make one more comment here. Our entire effort to stop war in space right now is based on a threat of unacceptable punishment, deterrence, retaliation if an attack on space systems comes. That attack is on the Earth, from the Earth, and it is not internationally equitable, proportional, or proportional. It's also not particularly credible. We have to be able to defend space from space, and eventually be able to defend all the nations of the Earth from space as well, in my view.
Yeah, I'll just say that, you know, it really depends on what you consider to be a weapon. If a spacecraft is maneuverable, it's a weapon. I mean, it has velocity, it has kinetic capability. So, you know, you don't even have to have a payload to turn your spacecraft into a weapon. So I would argue that it's already there. Also, you know, electronic warfare is a big part of modern warfare, and you don't have to even touch the spacecraft to jam it. And so, you know, denial of services that are provided in space, position, navigation, and time, things like that. So I think it's going to be very difficult to just stop putting weapons in space. I think that there is an important point to be made, which is everything that goes into space, we have to launch it into space. I mean, it's a pretty intentional act, and it's easy to monitor. It should be easy to monitor launches, and so we ought to know what is up there. And I think there are things that can be done with international coordination, just to make sure that we have at least awareness of what is going into space. I'll just leave it at that.
Yeah, and I'd agree with Glenn and Everett. I mean, I think this issue of a dual use capability is a key point, right? That whatever technologies you have to maneuver your satellite, to remove debris, for example, was mentioned. That can also, if you can remove a piece of debris, you can also remove an active satellite, right? Someone else's satellite. And so these technologies, it's really about the intent. How are you intending to use them? How are they going to be used in the future? And interestingly, there have been proposals for treaties banning weapons in outer space. So Prevention of an Arms Race in Outer Space, the Paris Treaty, or Prevention of Placement of Weapons in Outer Space, PPWT, proposed by Russia and by China historically. And it's been the US that has actually pushed back against these, in part because of this issue of intent and what effect would these treaties really have, and would they have their intended effect. So there's discussion of it, but challenges that have prevented it so far.
Also maneuverability and electronic capability is also a defense mechanism, right? So your ability to defend yourself against an attack can also be related to your ability to maneuver out of the way, or change your transmitting frequency or whatever. So they go together really. Weapons and the ability to avoid an attack.
Great, thanks. These were great comments. What I wanted to turn a little bit to is what we keep coming back to is of course, around dual use nature of some of these technologies, but also where they come from, in particular the commercial sector, in addition to the strong role it plays. And what I'm curious in talking about all the rules for space and so forth in the future, how do you envision a table, so to speak, of who's going to help come up with this role? Can somebody shed light on, what role should industry play when it comes to devising some of these rules of the road, because they play such an important thing, and it's kind of unprecedented in a certain sense. We keep talking about the states, but should SpaceX be at the table or something like that? I'm going to turn first to Mariel, only because she is straight ahead of me. Then I'll go to Glenn, and then I'll go to Everett if you have comments that way, just so you don't jump all at once.
Sure. It's a good question, Larry. And I would say, absolutely they need to be involved. If you look at the proportion of space activity that is done by commercial actors, I think it's at least half. It's a huge portion of the objects that are up there, and a very quickly growing proportion, right, with the mega constellations, which are commercial. So yes, they need to be involved. And from the bright side, I think they are involved to an increasing extent. So at least in the United States, when you see, the FCC, for example, was looking at new rules recently related to space debris and creation of debris, they are interacting with the commercial sector and getting feedback on what they're doing. And so, yeah, I think it's really important. I do think there are some proponents who say they can kind of almost handle it themselves, that they have a natural incentive to not want their satellites to, or their constellations to be destroyed, since they rely on that for revenue. I wouldn't go quite that far, right? I think that they also have incentives to do things as cheaply as possible, right? And so you want to make sure, and they don't necessarily have national security issues in mind. And so I think you do need to have all of those actors at the table. And you do need to have some actual regulation of the commercial entities. But certainly they need to be involved. And I think it's, this thread, I think you see across all these areas of technology having, both benefits and challenges, right? And so, we've talked about some of them with respect to maneuverability and how that can be a national security concern, while also being, necessary, for example, as Glenn was mentioning, for you need maneuverability to move out of the way if we're going to have active space traffic management. You also have things like with the SpaceX mega constellation, we want to have really good visibility of these relatively small satellites so that we can have good space situational awareness data, good space domain awareness data. But at the same time, you now have astronomers complaining because there's so many objects that are almost too visible. You can see them with the naked eye, just in the night sky now, and it's interfering with scientific studies and with amateur astronomy as well. So, I think with all of these technologies, we run into this issue of benefits and challenges.
Yeah, I mean, we absolutely have to get started on this, and it has to be international, and it has to involve private industry. I would I would assume the United Nations is the right entity to administer this. And I think there are precedents. I really look at things like maritime law, and that we just had, for example, the Suez Canal Ever Given incident, and there was tremendous international cooperation to resolve that, right? Because there was such a huge economic impact to that. So I think it can be done. I think there are precedents. I think we have to look at these other transportation domains and kind of view space that way. It is special in the sense that orbits have certain properties. The dynamics are a little different, but the clock is ticking. Like we really need to be thinking 20 years ahead and building the laws that will get us there, the regulations that will get us there in the next few years, so that we're not like always playing catch up.
Yeah, the strong regulations that we have tend to be legal liability regulations right now, and they're long established, et cetera, who the state, the launching or the operating state has liability. And you have to look at why then did we get such a commercial outpouring beginning around 2005 in the United States. Well, of course, dot-com billionaires or whatever you want to call it had the money to do it, but they also had to be licensed by the state to be able to do that. In the Cold War, it simply couldn't be done. You couldn't have someone launching rockets from their backyard. It might look like a nuclear strike. So commerce has exploded. SpaceX is leading the way. Branson and Bezos and Musk are leading the way. They're coming up with tremendous advantages in technology and space that could potentially benefit all of humanity and may have serious security risks as well. So that genie's out of the bottle, and what we have to do is we have to find ways to adapt those technologies, and they're changing so fast, and we don't know what the next technology is going to be that changes everything. The big one would be some change in propulsion technology that doesn't force us to be in this delta V construct where fuel is essentially the lifetime of a satellite. And so the most efficient ways of keeping a satellite in orbit in space are in orbits, which are easily defined, et cetera. And if we could get constant propulsion from some new technology, that would just change everything about the way we do things. But here comes the real rub for me is as a good American free market capitalist, whatever, how much of our national security do we want to offload to private business? I'm very concerned about something like that. Should we just take a technology and adapt it for national security as it develops, or should we guide that? In other words, do we follow or do we lead? Well, historically, we've tended to do both, and we're going to continue to do that. But it's a question that requires really dynamic international and national efforts, and some of it's getting messed up in a sense. The United Nations has long been the sounding board for how we do this. Rules of the road, including Paris, sometimes look. Every state is going to be aggrieved by the particular set that's been approved. The most recent one, I think, has a lot of legs in December. But then the United States has done some things with its domestic law to extend out to the asteroids, which probably is not something that is in consonant with international law. The technology is going to be, it's growing, it's expanding, it's changing, and it's accelerating. And we're going to use it, we're going to adapt it, and we're going to make mistakes. Hopefully, we can come up with a strategy or process to mitigate that.
Great, thanks. And I want to be conscious of the time, and so what I'm going to try to do is combine kind of the last question here with a number of questions, and I'm going to try my best to do so. What I wanted to pick up on, and to maybe throw Everett's question back to others in a roundabout way, of thinking about what would happen, combining with Jonathan's more question, if and I'm gonna alter it a little bit. If you had a massive a company the size of SpaceX outside the United States launched something similar, this large constellation or something like that, to basically show there's a private taking shape that's outside of the United States. It's not the United States. And I think that probably gives, from the U.S. national security perspective, a little bit of comfort knowing that many of these they might be international, but in a certain sense, they seem like they're part of the United States that way. And I want to also throw this question in there to kind of ask, what is this asking Glenn and Marielle, do you all see this as a concern of the increasing privatization of this sector, so to speak, and where might you push back when it comes to the national security concerns from that perspective? Because you might have very different ones coming from, say, where Everett's perspective, not just professionally, but of course possibly personally, might have a little bit different of a take. I hope that's clear in terms of where I was going, and if not, feel free to ad lib and pretend like I asked a different question.
Yeah, I mean, I think there are tremendous challenges with privatization and just the globalization of space and the increased participation in space, which I don't view as a problem. I view that as an opportunity. I think that's the direction we want to go in. That's what we want the future of space to look like. But I totally think that this is where national governments and international agreements come into play. I mean, you have to launch a spacecraft from somewhere. You have to have a launch facility to do that. Even if it's privately owned, it's within the sovereign domain of a government. If that government is a participant to a treaty, if this company is acting irresponsibly in some way, they have created a collision in space, or they're not protecting the spectrum appropriately, you shut them down, right? I mean, that's you take away their ability to launch. Now that is a reactive approach, right? It doesn't prevent the first offense, but I think if you have a system like that in place, and nations are signed on to it, then I think that you can have some control over what happens. But we have no system like that, right? I mean, I think that's where the need is we have to create a system like that, and then we have to encourage all of the kind of spacefaring nations to support that and agree to it. So to me, that's where the work needs to be done on the policy side.
So I'm happy to go next. So to your first question of, what happens if another country starts doing these types of activities and, having a lot of launches, having mega constellations, I would say that's happening. I mean, I think SpaceX is way out ahead of everybody in terms of the number of launches and objects they're getting up. But if you look at the trends in space activity in China in particular, they're really ramping up quickly, including in their commercial sector. And so you're seeing, and there have been years already, I believe, where the number of launches out of China has surpassed the number out of the US. That may not be true the last couple of years with SpaceX really ramping up, but there have been some cases of that. And they're registering mega constellations, plans to launch mega constellations with ITU, with the international body that regulates that activity. And so, I would say that's happening. And so we need to be prepared for that. And I think, the way that the US can best prepare, to me, is to be a leader in terms of what are going to be the types of restrictions that we put on these activities, the way we monitor these activities, to really set those norms, right? So that when other countries start to get those constellations going, that they're already as an example of responsible behavior and more incentive or pressure to kind of follow those guidelines. So I think the quicker we can, get those set up in the US context, the better. And then also it's reason to engage, both on the international level, but I would argue even bilaterally with China, if they're going to be the next ones to put up mega constellations, understanding what they're doing, the way they're approaching it, trying to get some common ground there, I think is going to be important. And similar with the question on privatization and the impacts of that, I mean, I think, again, it's happening, the cat's out of the bag, I think as one of the other panelists mentioned. And so I think I don't worry about it too much, in the sense that, as Everett said, within the Outer Space Treaty, the nations have the responsibility to regulate behavior of actors within their country. I think that is happening. And I think it's really just a responsibility to continue to do that, ensure that those commercial actors are following these same regulations and responsible behavior that states are agreeing to on that level, right? To really not abdicate that role. So I think I'll leave it there.
Yeah, there's this idea of the large mega constellations of small satellites all linked together by laser comms, that's the future. That's the way we're going to do it. It's not that a satellite passes over once every 2.5 days or something, you can get some access to it. What we're looking at is constant access to space for capabilities. So it's capabilities, not satellites. And it's a big place. I realize it's crowded. It's getting more crowded. There's dangers, but some estimates go up as high as a 250,000 of these satellites could be managed in space if we did have an international space traffic management system. So it's going to force us to go into that direction sooner. The other thing is we're getting all sorts of capabilities in space. There's a dozen countries now that can sell you a picture of the Earth, a pretty timely picture of the Earth if you want to buy it. And so what that is doing is increasing a huge amount of transparency. When Google gets its mega constellation network up, we may be getting streaming video of every point on the Earth that you can bring to your computer. That's going to create new business models, et cetera. One of the problems that the United States and other countries have is we want to be seen as a responsible actor in space, but it's our word for it for the most part that we're doing the right things. The more constellations we get by more countries acting, the more cooperation that's going to be necessary just to do it. And the more you'll have multiple sources of attribution for bad behavior. And I rather than stop it, I think what we just need to do is try to manage it to the extent to make it make business actually become more profitable in space, and we'll be just fine.
Great. This is actually thanks so much for these comments. It's actually a wonderful way to wrap up. I want to give my deep, heartfelt appreciation for all of these really interesting and insightful comments from our panelists and from the questions from the audience and their participation and so forth. I will, in a very timely manner, hand it back over to Raleigh to close this out. And once again, thank you. And thank you to FPRI, our sponsors, and many different sponsors. And I'll sign off for now. Thank you very much.
Thank you. Thank you to our panelists and to Larry for putting this all together. That was a fascinating discussion and one that I think we're going to be having to pay much more attention to in the future. A lot of opportunities, but potential perils as well. Again, say thank you to our supporters and our members. If you're not yet in one of those categories, please consider donating to us. We cannot bring you these programs without your support. We've also recorded this today, and so you can watch it again or share it with your friends and contacts. Just go on our website or on the FPRI YouTube channel and you'll find it. Finally, we really appreciate your feedback when you fill out the feedback form that comes as part of your registering for this event. So please fill it out. We read that, we read every word of it, and we take it into account in designing our program. So thank you for those of you who dutifully fill that out, and please fill it out to those of you who don't. And so thank you again to all, and take care. Bye-bye.